So what I want to talk about today is to what some of our customers are calling lights out operations. So what that means is that you're running your NFV services with pretty much 100% operational automation. So in order to do that, I first need to explain a little bit about who we are, what we do. Then I'll talk about why brutal automation is required. I'll then go into the three things that we believe you should do in order to achieve 100% operational automation. And after that, I'll show you a short demo as well. So bear with me today. So first, a little bit about us. So our company is Accanto, and we are based in Finland as well as in the UK. We're a software company, and our product is basically called Stratos. So what Stratos does, it's a set of automation tools that fully automates the operational lifecycle of network services. We have a bunch of engineers that are coming from a lot of companies like Cisco, like BT. So we have a lot of really, really smart engineers in our company. So you notice that I changed the word orchestration into automation here. And what we see at this show is that there's a lot of companies that talk about automation, and what they really mean is that they automate the day zero scenario. So that means that they are really looking at automating of the onboarding of VNFs. Well, Accanto is a little bit different, so we distinguish ourselves by also focusing on automating the day one and the day two scenarios. So once your services are already in production, we believe that there's a lot to gain there. And recently, when we have deployed these services together with IBM all around the world, we actually have seen that by using our tool, we're able to reduce the amount of manual effort that it requires to launch these kind of services, to run these services, with about 30 times, which is really, really massive. So if we look at the kind of traditional world where you have a physical appliance, you notice that it needs a lot of manual manpower in order to get that up and running. You need to order it, you need to ship it, you need to test it. All of that requires manpower. The only thing you can probably automate is the provisioning aspect. So that is by using, for example, a tool like Workflow to provision that box. Now, if you look into the virtual world, that same physical appliance is now made up out of tens, maybe 15, 20, hundreds of different software components. All those software components have their own life cycle for installation, for shipping, for testing, for healing, for scaling. And all these life cycles need to be programmed. If you look at, for example, Etsy defines that each VNF has about 13 different life cycles. All those life cycles need to be programmed. So when you go from the physical world into the virtual world, all of a sudden you have to think about manually programming 13 times more life cycles. And when we go a little bit more into detail of that, so when you look at the different life cycles, there are primitive life cycles and there are advanced life cycles. So for a VNF, for example, when you look at the primitive life cycles, those are mapped during onboarding. So you have your start, your install, your stop, and these are mapped to VNF-specific device commands in order to turn that on, to stop that, etc. So that's quite easy to program. Then if you look at the advanced life cycles of the VNF, where you have to do your scale, your heal, your update, your upgrade, those are already more difficult to program because you have to apply logic there. You have to, for example, define healing policies, etc. Well, if you take the same concept and you then go into a, let's say, more network service, so each network service can consist of maybe 5, 10, 20, 100 different VNFs. All those VNFs have those 13 life cycles that need to be programmed that I just discussed as well. The network service itself also has a life cycle, so you need to be able to instantiate the service, deploy the service, but also these advanced life cycles, which are extremely complex to program, you need to be able to bring the whole service into a scale, heal, whenever that's needed. So all that manual programming becomes very complex when you think about full network services. So manual programming of all these service life cycles, and remember, there are 13 more than in the traditional world, and when you go up to the network services level, these will basically explode. So all that manually programming of service life cycles results in a very error-prone operational environment. So first of all, because you have a lot of this workflow that needs to be written, it takes a lot of time to design and to implement the service. Second of all, because you have all these different life cycles, you have manual programming, and humans are not perfect, there will be errors. That means that if the service is not well tested, and you pretty much can't do that if you would have to manually program all these life cycles, you can't really test all these different variations before you put the service into production. So you will see more errors. And if you have more errors, you also need more people to resolve those issues. The more complex the service, the more longer it takes. So I think what we are seeing is that applying the traditional OSS tools in the NFV world, it doesn't work. It doesn't bring the automation benefits and the automation that is required to launch and operate these services. So what do we see? So we see that there are pretty much 3 steps that are needed to achieve this operational automation. So the first step is an intent-driven orchestration. So this applies brutal automation to once the services are in production. So it means that we're automating most of the life cycles that we just discussed, and I'll show you that in a bit. The second part to achieve operational automation is we need to be able to reduce the operational errors. Now, in order to do that, as part of the whole orchestration, let's say DevOps toolchain, we need to introduce behavior-driven testing. So before the services are going live, it needs to be properly brought into all its life cycles and fully tested. And the third part, once you have reached this step, and maybe you've already automated about 80% of your operations, we also can apply AI in order to, let's say, whenever something really goes wrong, we can apply AI to provide additional diagnostics to figure out what's wrong and then trigger, for example, heal or skill or an upgrade. So let's go into detail in each of these. So first, intent-driven orchestration. So intent-driven orchestration for us is kind of like a satellite navigation system. So when you go to your car, when you drove here perhaps this morning, the only thing you do is that you basically put in where you want to go. The system itself will figure out, okay, here I am now, I need to go to this place here in The Hague, and all the way it will calculate automatically, it will generate a path for you, which is the best way and the fastest way to get to your destination. You didn't have to manually program any step, any street names, any turns yourself. You can trust the system to get you there in time at the right place. And if something goes wrong, like a traffic jam, basically the system will automatically reroute you to still get you there. Now, intent-driven orchestration pretty much works in the same way. So when you look at the VNF, we just discussed these 13 life cycles for a VNF, you still need to manually program the first, let's say, primitive life cycles. So you need to do, during your onboarding, you need to map your installation, your configuration, your start. But intent-driven orchestration means that operations like scale, heal, upgrade, migrate are all automatically executed by the intent engine. We just said that the higher up you go, the more services you get, the more VNFs need to be kind of manually programmed. With an intent-driven orchestration, you don't need to manually program a single life cycle of the network services. So this sounds really amazing, and we have a demo that we can show you and we will run you through. But this is brutal automation that we're talking about. No more manual programming. So the second step was this behavior-driven testing. So once I have my service designed, once it's instantiated, we need to be able to test the service. Now, very often our product Stratos is kind of put into a DevOps environment. I think the previous speaker also discussed about that. So you have, for example, GitLab, where you keep your source code. You have then Jenkins, which automatically triggers builds whenever something changes. So imagine a VNF developer. So VNF has changed. It is put into GitLab. After that, that triggers a build into Jenkins. So it's building basically all the components of the service. At the end of that process, Stratos kicks in with a full behavior test. So once your service is, let's say, building, after that, it is fully automating the installation of the production environment, or the test environment in this case, somewhere in the cloud. It then spins up the full service, so it instantiates the service, puts all the VNFs there in the right order, in the right time. It then injects diagnostics traffic. So, for example, it injects a traffic generator, puts some additional probe there to monitor, and then it runs through a full set of tests that you have defined. So once that's done and it's all passed, it basically removes everything from your test cloud, and then the service is ready for deployment. The same thing can also be applied to a ready for service test. So before or when you put your service into production, at the end of that instantiation process, it should, and Stratos will run a fully executed and automated set of tests that drives traffic through that service to see if everything is functioning before it says, yes, green tick mark, now you're ready to go. So once we are introducing these two concepts, so you are using intent-driven orchestration to kind of productize all the life cycles for the VNFs and for the servers. Then you have also reduced the amount of errors by using this behavior-driven testing. The last step is that something will go wrong, like the previous speaker said. Something will go wrong. So when something goes wrong, we can use artificial intelligence in order to diagnose the issue and then help solve that. And together with IBM, we have made one scenario, which we're going to show you as well today. So imagine a global voice service. The global voice service consists of multiple locations, and the service itself is running fine. So everything looks green on your nice dashboard. Everything looks green. All the calls are being handled correctly. However, there is something odd in the service somewhere, right? So there's an anomaly that gets detected. So that anomaly detection can then trigger a diagnostics test. So Stratos will pick that up. It will run the full diagnostics test on all these different locations. All those metrics are pushed into Kafka, and Watson, in this case, from IBM, can then take that information, can take those test results and all those metrics, and compare different locations to each other. It can figure out, okay, where is there this kind of odd behavior? So it then finds out where that issue is, and it then triggers additional diagnostics more focused on that specific location. Then it will find out what the issue is. Some of the tasks will fail, and it will then issue a heal of the solution. All of that in a fully automated way. And this is what I'm going to show you today. So I had some issues this morning when I realized there's no laptop here on the screen, so I can't actually just kind of stop the video. So I need to ask the gentleman in the top to pause the video every now and then because I want to talk you through it. But this scenario we're going to play out here. So, in order to have a service, we first need to start it, but before that even, we need to design it. So I'm going to show you here how that looks like in Stratos. So this is the UI designer, how you would design your service. So this is the global voice service. You will see a few of the VNFs here, and this is the only thing you need to do. Can you please stop it? So this is the only thing you need to do to define and design your service. It's a global voice service. We have multiple gateways here. We have one in London, one in New York, and then there's a more kind of core voice server that is required. And what we do is, again, we are not programming any lifecycle here. All we do here is design the service itself, what are the components that are in that, and then also define what are the relationships between these components. So do I need to install VNF1 before VNF2? Does VNF2 need first to get the IP address of VNF1 in order to configure itself, etc.? So that's what we're defining here. Please continue. So you'll see here some of those properties, and some of those arrows are basically the relationships between the VNFs. Once you're happy with this, you can then put this into your production. So you're going to create an active instance, and from here on, this intent engine, or this intent-driven orchestration, basically kicks off. Please stop. So what you see here is kind of an internal look at the intent engine. So as you saw, the only thing I did was I just defined the service, created the relationships, and that's it. So now it is kicking the full service into gear. So what it's doing here, you see the global service on the top, and underneath are all the different VNFs that are going to be installed, configured, started, stopped, all in the right order. And again, I have not programmed a single lifecycle. I have not programmed that VNF to be there, that VNF to be there. I have just designed the service, designed the relationships, and let the intent engine, just like your satellite navigation system, take care of bringing this from an inactive state into an active state. On the top, you will see this kind of RFS. We talked about this server behavior testing. So once you've instantiated the service, you then can trigger automatically this ready for service testing. Please continue the video. And you'll see this here. So you see all these VNFs being brought to life in the correct order. And again, I'm just looking, I'm just a spectator here. I'm just not actually programming anything here. So once it's complete, you'll see it go through a ready for service test. So this is all instantiated, and it's now kicking off this ready for service test. Please stop the video. So what you're going to see now is that on the left side, you see all the components that are being brought to life, but there's no traffic. There's no traffic yet here. So you'll see the green lines pop up. What the service behavior testing is doing is that it's automatically injecting traffics. So it's creating, in this case, a couple of SIP-P VNFs, which will make voice calls on behalf of the test. So you'll see the traffic flowing through. Please continue. So once the traffic is there, it will then run through a full set of automated tests in order to see whether what you have instantiated is actually working correctly. We also have all the metrics in Kafka, so we can display here, for example, the amount of successful calls. Please stop. It's funny how to do this, by the way. So now the service is up and running, everything is green, and what we're going to do is we're going to manually force anomaly. So even though the service all looks green, we're going to manually force an issue. So an issue, this case, is one of the gateways. We're going to misconfigure that so that the load of all the SIP traffic, all the voice calls, is not spread evenly. So one will have less traffic than the rest, which is weird, which is an anomaly. And that will then kick off an automated diagnostics test. Continue, please. So once the anomaly is detected, the diagnostic service is basically automatically executed. So it will run through a full set of tests. It will inject traffic again. It will include additional metrics or additional probes to monitor the service. And you'll see it goes through a lot of different test cases here. All those test cases, please stop. All those test cases are put to Kafka, where Watson, in this case, will analyze that data. So we've just run a full service test from all the locations. Watson will then pick up those metrics from Kafka and will analyze with the data and say, okay, everything is working fine, but here in the London area, or in the London gateway, something funny is going on. So let's inject an additional diagnostics there in order to find out what the problem is. Please continue. So that's what happened here. So Watson has analyzed the situation. It knows that the London gateway, there's a funny issue there, so let's try and deploy an advanced diagnostics in the specific London gateway. And you'll see that the last step here will fail. And then what then happens is that Watson picks that up. It sees that the London gateway has an issue, and it will kick off Stratos to request a heal. So the intent engine will then pick it up, and you'll see that the heal is being carried out again with zero manual programming. So you'll see now that the intent engine is basically running again. It has diagnosed, Watson has diagnosed that the London gateway is the issue, and it has now requested the heal, and the heal is now in progress. Basically, we're stopping the service, we're removing the dependencies in the relationship, we're then starting the service again and adding back the relationship. So this is the way to get your service into full production without any manual programming. So maybe just to conclude, I think I'm just in time here, so just to conclude, so what is the end goal for all of us sitting here? I think it's to deliver commercially viable NFV services. So what we've seen is that because of the complexity, because of all these manual programming, of all these life cycles, traditional OSS systems are simply not good enough. They're not good enough, they do not provide the operational automation that you need to make commercial viable NFV services. So first of all, you need intent-driven orchestration that will enforce this kind of brutal automation so that all these life cycles do not have to be manually programmed. Second of all, you need to reduce the operational errors. So you need to reduce the operational errors, which means that you need an integrated behavior testing, that all the services are tested before they go live, and also in a very automated manner, like I just showed. So once you've reached this kind of 80% operational automation, you then need to apply AI, and we've just shown you one example here, how you could use AI to trigger additional diagnostics and then request more diagnostics and then recover a broken service or request a heal, for example. So this is what you need to get towards kind of a lights-out operations and 100% operational automation. Now, this video was very short. We're showing the full production system downstairs. We have a booth in B10, and also our CTO is speaking tomorrow. I think it's 10 past 10. We did not pay for getting the B10 and the 10 past 10. But yeah, so that was my presentation. any questions?
Thank you very much, Victor. Any quick question, or you can, I think, see you at the booth, Victor. Is there a question at the back? Right.
Yes.
And we've got a microphone. Excellent. Just coming to you.
Yeah, I'm Dilip from Ericsson. With regards to your auto diagnostics or behavior testing which you do you have predetermined abnormal scenarios you create and based on some relevancy, and then you go through this test and identify, okay, what went wrong, and then when you come to auto correction, you have some algorithms to use to do the auto resolution?
Yeah, so in this case, so when you design the service, you also design the test that are associated with that service, so that's part of the design process. So when you run the full service test, it will check all the different locations in this case. So then secondly, in this case, Watson compared those two locations, or three locations in this case. It spotted that there was an anomaly on one case, and it then triggered additional diagnostics in that location. So those tests were predefined, correct? But they are basically, when you're designing the service, you have a service test, and for example, for your one location, you can also have a test. So kicking off this whole automated test, that was kind of fully automated. We didn't do any kind of manual work there. And Watson did all the brain power behind in order to determine where the issue was, kicking off the additional diagnostics, and then requesting the heal. Yes.
Okay, thank you very much indeed.